Okay, hello. This is Math 1440, and I'm just going to do one Exam 2 review problem. It's a double integral. So we got the integral from 0 to 1, and then the integral from y to e to the 2y of 2x dx dy. So here's what I like to do when I have a double integral. I like to draw these brackets here because that's like my inner integral. This is the inner integral, and it's with respect to x. So, and then once I get that answer, I'm going to do the outer integral, the integral from 0 to 1 of this answer dy. Okay, so I've got an option. I can either do this integral the way it is, or if I wanted to, I could pull this constant factor of 2 all the way outside. It really doesn't matter. You'll get the same answer. I guess I'll do it the way it is. So let's do the inner integral first. So inner, and we've got the integral from y to e to the 2y, and then I've got 2x dx. And this is going to equal, so I'm doing the inner integral first. We got the integral from y and then e to the 2y, 2x dx. So here again, I could pull out the 2, but I'll just leave it where it is. Either way, you get the same answer. So this 2 is going to be part of my answer. And then what's the integral of x dx? We're integrating with respect to x. So it's going to be, by the power rule, x squared over 2. Now that I have the antiderivative, because whenever you're doing like a definite integral, you first do the antiderivative, and then you evaluate. And because this is with respect to x, I'm going to evaluate from x equals y to x equals e to the 2y. Again, because this integral is with respect to x, these limits are in terms of x. So if you want to, you can write x equals y to x equals e to the 2y. That makes a little less likely to make an error when you do that. Okay, and then before I do these substitutions, I'm going to simplify. Let's strike out these 2's. 2 over 2 is just 1. So really it's just x squared being evaluated. And you always begin with the upper limit first. So wherever I see an x, I'm going to write e to the 2y. So this is now going to equal, and instead of being x squared, it's going to be e to the 2y squared. And then minus, and now we're going to input the lower. So it's always minus, and then you input the lower limit. So wherever I see an x, I'm going to write y. So instead of x squared, it's just going to be y squared. And then we can simplify that. A power to a power, the rule of exponents tells us to multiply the powers. So this is just going to equal e to the 2y times 2 is 4y minus y squared. Okay, so that's my answer for the inner integral. Now let's go to the outer integral. The outer integral. So I'm going to write outer, and the outer integral is 0 to 1, and then we input our answer, e to the 4y minus y squared, e to the 4y minus y squared, and then we're going to write dy because we're doing the outer integral, which is with respect to y. So dy. And if you want to, parentheses are optional there. Okay, so now we're integrating with respect to y. And here we go. So the first step with this definite integral is to first just do the indefinite integral, the antiderivative. So what is the integral of, the integral of a difference is the difference of the integrals. So what's the integral of e to the 4y? It's going to be exactly what you see, e to the 4y, but then it's going to be divided by 4. Remember, the derivative of e to the 4y is e to the 4y times 4, but the antiderivative you divide by 4. If you don't feel comfortable with that shortcut, just do a u substitution. The integral of e to the 4y dy, let u equal the exponent 4y. And with that u substitution, you'll get this same answer eventually. Okay, so I'm done with that first integral. Now it's going to be minus, what's the integral of y squared dy? Well, by the power rule, is going to be y cubed over 3. Now that I have my antiderivative, we draw the evaluation bar. This is with respect to y, so if you want to, you can write y equals 0 to y equals 1. So now we're almost done. All I got to do is input the upper limit first. Wherever I see y's, I'm going to write 1s. So let me continue over here. So this is going to equal, and it's going to, wherever I see y's, I'm going to write 1. So it's going to be e to, 4 times 1 is 4. So the exponent is going to be e to the 4th over 4 minus 1 cubed is 1 over 3. Let me just drop back so you can see what I'm doing here. So I let y equal 1, so you can see you got e to the 4th over 4 minus 1 over 3, inputting in there. And then we got to go minus, and then we let y equal 0. So now it's going to be minus the expression. When I let y equal 0, I'm going to get e to the, and then 4 times 0 is 0. So I'm just going to write e to the 0 over the 4 minus, and when I input the 0 here, 0 cubed is 0. 0 divided by 3 is just 0. So I'm just going to write 0. Okay, let's simplify this. So now we're going to get e to the 4th over 4 minus a third minus, and now isn't e to the 0 1? Anything to the 0 power is 1. So instead of writing e to the 0 over 4, let's just write 1 over 4. And then it's going to be plus 0. Minus a minus is plus 0. But I don't have to write plus 0 because that doesn't change anything. So I get e to the 4th over 4 minus a third minus a fourth. Let's get a common denominator of 12. So let's see. I've got a choice here. I can just add these fractions with the common denominator, or I can just get a common denominator of 12 for everything. I think the answer key for this problem, because I got this problem from the exam 2 review sheet in the website math.unm.edu. So I think the answer key, I'll match the answer key. So let's write e to the 4th over 4, and then if I want 12 as my common denominator, I got to multiply 3 by 4, but whatever you do downstairs, you got to do upstairs to get an equal fraction. 4 times 3 is 12, so I'm going to multiply the numerator by 3. So this becomes, the numerator is going to be 4 over 12, so I'll just take my time here. Let's write minus 4 over 12 minus 3 over 12. So in other words, another name for 1/3 is 4/12. Another name for 1/4 is 3/12. And then we can combine like fractions. And isn't dividing by 4 the same thing as multiplying by 1/4? So you can either write it like this, or I think the answer key probably did this. 1/4 e to the 4th minus, and now, since we have a common denominator, we can write a single fraction with that common denominator of 12. And then the numerators we combine. What's a minus 4 minus 3? It's a minus 7. So minus 7 over 12. And that's my final answer. 1/4 e to the 4th minus 7/12. I'll box my final answer. Okay, so I'll stop there. Good night, everyone.